Hi folks, here's the video starting MUC, which we will do more of on Wednesday. It's for higher order ordinary differential equations and with constant coefficients linear. So just like we've done already with MUC in first order, now it's for second order. You might hear my cat Blaze meowing in the background. I'm not exactly sure what he wants. Let's solve y double prime minus y equals this stuff with initial conditions. There are two of them now because it's the second order. So y of 0, y prime of 0, both going to be 0 for our conditions. So our solution will be y is equal to a homogeneous term plus a particular term. And to go find the, let's do this, for y sub h, we're going to solve y double prime minus y is equal to 0. And that gives us m squared minus 1 is equal to 0 for your characteristic equation. That's going to be m equals plus or minus 1. That gives us a y sub h as c1 e to the, are we using t's for x's? c1 e to the t plus c2 e to the negative t. Now we need y sub p. For y sub p, we need an appropriate form of a particular solution that matches the right side. That was our cosine and sine. So we have a cosine 2t plus b sine 2t. Then we'll go find our coefficients, the a and the b, and you do that again by plugging y sub p back into the equation. So we're going to need more space. All right, so the equation was y double prime minus y is equal to, I think it was 5 cosine minus 10. 5 cosine 2t minus 10 sine 2t. We need, and our y sub p again was a cosine 2t plus b sine 2t. All right, so if we're going to plug our y sub p into the left-hand side, we need the second derivative. And first derivative is negative cosine 2t minus 4b sine 2t, and we're going to add that to negative y, which would be our y sub p times a negative 1. And then let's combine some of those things. Let's see. So we're going to combine these two, and then we're going to combine those two. And then, so we get negative 5a cosine 2t minus 5b sine 2t is equal to, and the right-hand side, 5 cosine 2t minus 10 sine 2t. This is the right-hand side from up there, right? Oh, right-hand side there, putting it right there. Okay, and then compare up your coefficients. Let's see. Negative 5a is equal to a 5. That tells us a is a negative 1. Negative 5b is negative 10. So b is a 2. And then we'll go back. Negative 1 and a 2. So we have negative 1 cosine 2t plus 2 sine 2t. Then to find C1 and C2, we use our initial conditions. So we need to take this thing. We're going to have to go differentiate it. All right. So our initial conditions, ooh, that was a -1, I believe. Okay, so we had y of 0 is 0. So with that condition, if we plug that into this equation, we have 0 is c1 plus c2 minus 1 cosine 0 plus 2 sine of 0. Sine of 0 is gone. So we got 0, c1 plus c2 minus 1. Let's call that equation 1. 1 is equal to c1 plus c2. Then with y prime of 0 being 0, we need the derivative of our current solution and then plug in 0. So y prime, if we take the derivative of all of this, it would be c1 e to the t minus c2 e to the negative t plus 2 cosine 2t plus 4, actually plus 2 sine 2t plus 4 cosine 2t. If we plug in 0, 0 is c1 minus c2 plus this term goes to 0 again, and then this term goes to 1 times 4. So 4 and 4, let's call this equation 2. 4 is c1 minus c2. So now let's combine equations 1 and 2 and come up with a c1 and c2. All right, if we just add these two equations up, then 5 is 2c1 and c1 is 5 halves. Then, let's see, I'm lazy. Then let's take that c1 and put it in there into equation 1. We're going to have 1 is equal to 5 halves plus c2. 2 over 2 minus 5 halves is equal to c2, which is -3 halves. So 5 halves, 3 halves. Let's go back to our equation. And I believe we said 5 halves e to the t minus 3 halves e to the negative t minus cosine 2t plus 2 sine 2t. There's our general solution. No, not our general solution, our particular one, because we found all of our undetermined coefficients and our constants. That is the same process you've done before, it just takes a little longer, and solving the homogeneous piece is different now. Let's look at one more, and just to show you how this works out, and then we actually won't find undetermined coefficients or any initial condition, any constants, we'll just set it up. So if you're going to solve this with MUC, you would decide it's linear with constant coefficients and it's second order, so we're going to use MUC to do that. Y is going to be y sub h plus y sub p. We're going to go find y sub h, find y sub h. So we're going to solve by solving y double prime plus 4y prime plus 4 is equal to 0. That's going to give us a characteristic polynomial of m squared plus 4m plus 4. That's an m plus 2 squared. And so we get an m minus m equals -2 repeated root. And it's real. So that tells us our y sub h is a c1e to the -2x plus, and we would have a c2, again, e to the -2x, but then these two would be dependent on another, and you have to make this one, or one of them, you know, you might as well pick this one to be independent from the other. So let's take the exponential piece, let's scoot it over, put in the independent piece. Great. Now we need a particular for y sub p. For y sub p, our right side is e to the -2x. So typically we pick a e to the -2x. But look, that matches, that's linearly dependent with their first term. So we come in here, we take the e to the negative 2x, move it over, throw in an independent variable, and now look again. This is now linearly independent with the first term, but your y sub p is linearly dependent with the second term, and that can't happen. So we need, but this is still linearly dependent with term 2. So multiply in an additional factor of x. So let's go with y sub p is equal to ax squared now, e to the negative 2x. Now, if we did that, ax squared e to the negative 2x, now we would have our linearly independent solutions. Again, we would need to go through a process to find the undetermined coefficient there. Then if we had initial conditions, find C1 and C2. All right, y'all take care. See you soon.